CS470, Project 2, Cloud Presentation, Cloud Development, presented by Kewanee, McGhee. Hello, my name is Kewanee McGhee. I'm a student at SNHU and a full-stack developer. In the course, we learned how to migrate a full-stack application on our computers to the serverless cloud with Amazon on the web. This is my presentation on the intricacies of the cloud development process. I will try to explain the process in a way everyone can understand, with the hopes that once I am complete, you too can deploy your own application using Amazon Web Services. We will cover a traditional full-stack web app to cloud-based deployment on Amazon Web Services. We will also cover the intricacies of cloud development using containerization and orchestration using the serverless model with Docker and Docker Compose. Go over API logic and databases on the serverless cloud using Amazon Web Services, Lambda, DynamoDB, and MongoDB. Lastly, I will go over some cloud-based development principles, how to secure your cloud application, and a short summary on everything you will learn today to make everything come together in a package like a container. So let's get started. Containerization is a method of packaging software applications and their dependencies into lightweight, portable containers that can run reliably across different computing environments, including development, testing, staging, and production environments. In a containerized environment, much like this ship taking containers of merchandise to be sold, applications run in isolation from the underlying infrastructure, which allows for increased portability, flexibility, and scalability. Each container includes all the necessary components and libraries to run the application, including the operating system, runtime environment, and dependencies. Containerization is commonly used in modern software development practices because it simplifies the deployment process and enables faster iteration and testing cycles. There are several tools that can be used for containerization of applications, including Docker, which is the most popular containerization platform that allows developers to build, package, and deploy applications in containers. Docker provides a set of tools and APIs for managing containers, including Docker Compose and Docker Swarm. Kubernetes is an open-source container orchestration platform that automates the deployment, scaling, and management. It provides a powerful API for managing containers and allows developers to easily deploy, manage, and scale applications. Apache Mesos is a distributed system kernel that abstracts CPU, memory, storage, and other resources away from machines and makes them available as a virtual resource pool. It can be used for container orchestration and management. Linux containers and Linux Container Daemon are containerization technologies that provide a lightweight way to isolate processes in Linux. LXD is a higher level interface to LXC that provides a more user-friendly way to manage containers. And OpenShift is a container application platform that allows developers to build, deploy, and manage containerized applications on any infrastructure. It is built on top of Kubernetes and provides additional features such as source-to-image builds and integrated CI/CD pipelines. These are just a few examples of many tools available for containerizing applications. The choice of tool will depend on the specific requirements of the project and the expertise of the development team. Now that we've learned about containerization, we will also learn about orchestration, which is a way of handling multiple containers. At least 2 containers will be needed to handle the front end, back end, and the database. Very much like a conductor who chooses to incorporate the flute in an orchestra at the right time, leaving the musician to perform their part, Docker Compose is a tool that allows developers to define, configure, and run multi-container Docker applications. It provides a simple and efficient way to orchestrate complex application architectures, allowing developers to focus on building their applications rather than managing infrastructure. Some of the main benefits of using Docker Compose. With Docker Compose, developers can define their entire application stack in a single YAML file, which makes it easy to manage and share with other team members. This simplifies the development process by reducing the time and effort required to set up and configure the development environment. Docker Compose allows developers to define and manage multiple containers as a single application. This also simplifies the development process and ensures that all components of the application are deployed and managed together. Reproducible and consistent environments. Docker Compose enables developers to create a consistent development environment that can be easily reproduced across different machines and environments. This ensures that the application behaves consistently across different environments, reducing the risk of errors and inconsistencies. With Docker Compose, developers can define the entire application stack in a single file and deploy it with a single command. This makes it easy to deploy and manage complex applications across multiple environments. You can build your containers in Docker and later use commands in PowerShell or Linux terminal window to compose these together, and a functional orchestrated container can be produced. Docker Compose provides a powerful and efficient way to manage multi-container Docker applications, reducing the time and effort required to set up and manage complex application structures. The serverless cloud. What is serverless? Serverless is a cloud computing model in which cloud providers manage the infrastructure and automatically provision, scale, and manage the resources required to run an application. In a serverless architecture, developers write and deploy code that is executed in stateless containers, which are managed by the cloud provider. Some advantages of using serverless are: serverless architecture eliminates the need for developers to manage and provision service, which reduces infrastructure management. It reduces the operational overhead and allows developers to focus on building applications rather than managing the infrastructure. Serverless architecture automatically scale up or down based on the demand for application, allowing developers to build highly scalable applications without having to manage the underlying infrastructure. Serverless architectures are also cost-effective because they only charge for the actual resources consumed by the application. This means that developers don't have to pay for idle resources, which can significantly reduce the cost. They also allow developers to deploy and update their applications quickly, which reduces the time to market for new features and updates. Serverless architectures are highly resilient because the cloud provider manages the infrastructure and automatically handles failures and scaling issues, reducing the risk of downtime and improving the reliability of the application. All in all, they provide a powerful and efficient way to build and deploy applications in the cloud, reducing the operational overhead and allowing developers to focus on building high-quality applications. Amazon Web Services Lambda allows you to add logic to Amazon Web Services resources, such as Amazon S3 buckets and Amazon DynamoDB tables, so you can easily apply compute to data as it enters or moves through the cloud. This diagram shows how Lambda and S3 can be used together to build a serverless application. The application code is uploaded to an S3 bucket. The Lambda function is created and configured to trigger on specific events, such as a new object being created in the S3 bucket. When the event occurs, S3 sends a notification to Lambda. The Lambda function retrieves the object from S3 and executes the code. The results of the code execution can be stored back in S3 or sent to other Amazon Web Services. This architecture provides a cost-effective and scalable way to deploy serverless applications without having to manage server infrastructure. Using a serverless API with Amazon API Gateway and AWS Lambda, we deploy our application safely to the web. This diagram shows how a serverless application can be deployed using Lambda and S3. First, your application code is stored in an S3 bucket. When a new file is uploaded to the bucket, an S3 event is triggered. The S3 event notification is sent to a Lambda function. Then the Lambda function retrieves the file from the S3 bucket and processes it according to your application logic. The Lambda function can then write the results back to the S3 bucket or then send them to another service or resource within AWS. This architecture provides a scalable and cost-effective way to deploy your application, as you only pay for the resources that you use and don't have to worry about managing server infrastructure. When using Lambda functions with a database, it is important to ensure that the connection between Lambda and the database is secure. This can be done by using SSL TLS to encrypt all data in transit between the Lambda function and the database. It is also recommended to use IAM roles and policies to restrict access to the database to only those Lambda functions that require it. MongoDB and DynamoDB are both popular NoSQL databases, but they have some key differences in their data models and query capabilities. Using MongoDB and DynamoDB on a serverless cloud service can offer several benefits for your application, such as being low maintenance, scalability, flexibility, and cost effectiveness. MongoDB is a document-oriented database where data is stored in flexible JSON-like documents that can have various structures. MongoDB data is organized into collections which can contain any number of documents, and each document can have its own unique structure. The schema can evolve over time as new fields are added or existing fields are modified. On the other hand, DynamoDB is a key value and document-oriented database where data is stored in tables that have a primary key and can have secondary indexes. With DynamoDB, each item is a JSON-like document that can have any number of attributes, but the schema must be defined up front. DynamoDB is designed for fast and predictable performance at any scale, making it fast and predictable and a good fit for applications that require high availability and low latency. To compare the querying capabilities of MongoDB and DynamoDB, some common queries that can be performed in both databases are simple CRUD, create, read, update, delete operations on a single document, querying for documents that match a certain criteria, documents with a specific attribute value, sorting and limiting the results of a query, joining data from multiple collection tables. The scripts produced to perform these queries will vary depending on the specific implementation of each database, the programming language used, and the specific use case. Here is an example of a script for performing the above queries in Python using the official drivers for each database. To integrate MongoDB and DynamoDB in your application, you use application code to handle data replication and synchronization between the two databases. When a user creates a new profile or post, the application stores the data in MongoDB and then replicates it to DynamoDB for backup and scalability purposes. When a user updates their preferences or makes a transaction, the application stores the data directly in DynamoDB and then updates the user's profile in MongoDB to reflect the changes. By using MongoDB and DynamoDB together in this way, you can achieve a flexible and scalable solution for storing and managing different types of data in your application. To secure the connection between Lambda and the gateway, it is recommended to use HTTPS for all communication. This ensures that all data is encrypted in transit and cannot be intercepted or modified by third parties. In addition, the API gateway can be configured to require client certificates for authentication, which further enhances security. Economically, cloud-based development principles like elasticity and pay-for-use models are essential concepts in modern software development. Elasticity refers to the ability of a cloud system to dynamically adjust the resources allocated to an application based on the current demand. This means that the system can scale up or down to meet the changing needs of the application. Elasticity is particularly useful for applications that experience spikes in traffic, such as e-commerce sites during holiday sales or gaming applications during peak hours. By scaling resources up during peak times and down during slower periods, companies can save costs while still maintaining optimal performance for their applications. The pay-for-use model is a billing model where users only pay for the resources they consume. In traditional hosting environments, companies would pay a fixed fee for a set amount of resources, regardless of whether they use them or not. With the pay-for-use model, companies only pay for the resources they use, allowing them to save costs and scale resources up or down as needed. This model is particularly useful for startups and small businesses who may not have the upfront capital to invest in large infrastructure costs. Together, elasticity and pay-for-use model provide developers with the flexibility and cost savings necessary to build and deploy applications quickly and efficiently in a cloud environment. Understanding your capacity and usage in Amazon Web Services is important for managing your costs and optimizing your resources. By monitoring your usage, you can identify areas where you may be over-provisioned and adjust your capacity accordingly. In Amazon Web Services, you are typically charged based on your actual uses of resources, not based on the capacity that you have provisioned. If you're storing data in S3, you will be charged based on the amount of data stored, as well as any data transfer or retrieval costs. Capacity refers to the maximum amount of resources that you have allocated for your application or workload. This could include computer resources or network resources. When you provision resources in Amazon Web Services, you specify the capacity that you need to support your workload. This can be adjusted over time as your workload changes, but there may be limits to how much capacity you can provision in a given Amazon Web Services region or account. Securing your cloud application is crucial to protecting your data and preventing unauthorized access. Being secure is a top priority in the cloud, and IAM policies are a critical tool for managing access to AWS resources. By defining policies that explicitly allow and deny access to specific actions, we can ensure that only authorized users or services can access our resources. It is essential to follow the principle of least privilege, which means granting only the minimum permissions necessary for an identity to perform its job. By doing so, we reduce the risk of unauthorized access, data breaches, and other security threats. Here are some other ways to prevent unauthorized access when using Amazon Web Services. Secure your network to isolate your resources and control inbound and outbound traffic. Encrypt your data using AWS key management services. Monitoring your app and resources. Keeping your software and operating systems up to date by regularly updating your software and patches with the latest patches and security updates. Lastly, using Amazon Web Services Security Services, which offers a range of security services, including AWS Security Hub, AWS Guard Duty, and AWS WAF. And these services can help you monitor and secure your Amazon resources. By following these best practices and utilizing security tools and services, you can help ensure the security of your application in the cloud. In conclusion, we learned about containerization and orchestration using Docker and Docker Compose. We also learned about the serverless cloud and how it works to deploy an application using Amazon Web Services with Lambda and S3 buckets. Next, we took a look at securing the connection between the Lambda and gateway for optimal protection. We got a peek at MongoDB and DynamoDB, two NoSQL databases, their differences, and some example code using the Python language to do some simple operations and modifications for an application. Finally, we covered cloud-based development principles, went over capacity versus usage, and secured our cloud application. Migrating your application to the cloud could provide significant benefits for a business. The three main advantages are increased scalability and availability, decrease operational costs, and simplify resource management. Cloud development simplifies the management of your resources and infrastructure. The cloud offers many fully managed services and serverless solutions, which automatically manage the required resources. This means you can focus on what matters most to your business rather than managing and maintaining data centers, servers, operating systems, and applications. This concludes my presentation. Thank you.